Hello, my name is Zach Harney. I'm in Lab Section M5, and this is my Lab 5 Part 1 video. As you can see in front of you, you have an otter with a parachute and a blue lizard. These are my objects for this lab, and I'll be referring to them later in this video. Okay, so the main objectives of this experiment were to test the momentum principle, or Newton's second law, which states the acceleration of an object depends on two factors: the net force acting on it and the mass of the object. We did this by tracking two different objects, one that only included the effect of gravity and one that included both the effect of gravity and the effect of drag, or air resistance. The system we used to measure the two objects was Tracker, and after uploading the video into Tracker, you can see we placed the origins here at its original location and calibrated the video with this calibration stick, and in this case I calibrated the window and measured it to be 1.575 meters. So here's the first example, video of the lizard, measuring purely gravity, not drag. As you can see, I measured the location of it after each frame. As time went on, the location got further and further away, indicating that it was accelerating. Okay, so here is the video for our second object, which was the otter with a parachute. As you can see, again, we used the axes and calibration stick. These are really just to find out what the distance is in real life, to kind of help create a proportion to it. I'll start again. Okay, so after using Tracker for the experimental model, I then moved on to Python to create a computational model for both objects and their path of motion. In this case, I'm specifically looking at the measurement for the second object, which was the one that included drag and the force of gravity. I basically had to change a few things, a few initial conditions, one of them being the initial position of the object, which I found to be minus 2.25 e to the minus 2. For both of them, I changed the time step to be 1 divided by 30, which is the basic one for Tracker. I then had to change the total time for each video, which in this case is 1.64. For this video, or for this specific object, I had to account for the drag force in the computational model. I had to account for the drag force in the computational model. The drag force was a constant, a proportional constant to the velocity. I used 0.01 as my value, because it best modeled it. I then ran the model, and that gave me my data for Excel. Real quickly, I'll show you running the model. This is once again the one for the force including drag. So here's the work I did in Excel. This is representing the first object, which only included the force of gravity, used to test Newton's second law. As you can see, the red dot is the computational media and the blue is experimental. Both data is on either side. As you can see, they're very similar. The shape and the shape of the curves are exactly the same, just a few minor differences. Moving on, I'll go to the next one, which also turned out to be very similar. The first one is, the blue one is a little different from the computational model, as that is probably just a factor from human error or just an error in the tracking system, but overall it proves the drag force and shows that very well. So lastly, we'll go over the what does it mean and what if question. Basically, it's what does it mean is asking which model predicts terminal velocity. In this case, the model including drag predicts terminal velocity. As you can see, it starts to level out in the graph, indicating that the net force is 0. For the what if question, it's basically talking about if the object was thrown downward. Drag is a good indicator of terminal velocity. As I mentioned earlier, the net force becomes 0 in terminal velocity, and at all points it would eventually reach terminal velocity. Just in this case, there was enough distance in between. So thank you for listening. Enjoy your day, and go Jackets.